So now how to calculate the AST? We are having the formula of AST as AST required is equals to 0.5 FCK upon Fy into bracket 1 minus under root of 1 minus 4.6 mu upon FCK BD square into BD. Here is how we calculate the whatever the mu we have calculated, we substitute in the formula and we get the moment, AST. Here it is 390.8 mm square. At this support it is 384.38 mm square. At this mid span 257.4 mm square. At this support it is 351 mm square. And lastly it is 257.4 mm square. Then after calculation of AST, our next step is to calculate the AST minimum, and AST minimum is equals to 0.12% of BD upon 100. Now as this span is continuous span, AST is calculated for the single span as the depth is similar. So here B is 1000, capital D is 150, and multiplying it by 0.12 divided by 100, we get the minimum still as 180 mm square. And if you observe all the area of steel calculated, even at the support and the mid span, our steel is sufficient or greater than AST minimum. Then we calculate the spacing. Now the spacing is equals to B into AST, small ast divided by capital AST. We assume hash 8 mm bar, and hence substituting all the values, small ast is equals to pi by 4 into 8 square. Capital AST will be differing from span to span. Here 390, here 384, here 257, 351, 257. Okay. So spacing over here it will be 150.05 means 150 mm, 195 and 195. Spacings are calculated for the span, not for the support. Okay. So we provide hash 8 mm about, here it is 150 mm center to center, here hash 8 mm about 195 mm center to center, here also hash 8 mm about 195 mm center to center. Then we calculate the SV maximum, that is the maximum spacing, which is equals to 3D or 300 mm, whichever is greater. So as 3D is D, small d is 120 mm, so 3D will be equals to 360 or 300 mm. So all these two values are very much greater. That's why we are providing our steel at these values only, 195 and 150 mm center to center. Then we have to calculate the distribution steel. As it is one way slab, we need to calculate the distribution steel. So here ASD is equals to 0.12 12% or 12 upon 100 into small b into capital D, and we have calculated this value previously also. Here it is 0.12 BD, it is 180 mm square. Now as our AST required is greater than AST minimum, which is 180 mm, our previous check is satisfied. But in this case we required the distribution steel, so we may assume 8 mm bar or a 6 mm bar. Okay, so 6 mm bar we are assuming, and we are calculating the spacing, which is equals to small b into small ast divided by capital AST. Here small ast is equals to pi by 4 into 6 square, that is the area of 1 bar, and capital AST is equals to 180 mm, and B is equals to 1000. Substituting these values, and we get the spacing for 180 mm bar as for 6 mm 180 mm area square, for 6 mm bar as 159 mm center to center. But as we cannot go higher than 159, we provide distribution steel has 6 mm about 155 mm center to center. Now here in the case of one-way slab, we need to calculate the extra top bars at the support. Let us learn what is this support steel first, and then we will calculate it. See here student, now what these extra bars are support steel is. Here the support moment is negative, okay, and the span moment is positive. Now what happens, the steel from this span will be entering in this span, and this span will be entering in the this span. So what we have to do is, so this steel is nothing but the movement. This steel will be satisfying this movement up to some extent, but we need to calculate which extra amount of steel will be required over here. Means what? Here area of the required steel is 384.38 mm square, but here this span steel will be 50% of this bent up bar will be over here, also 50% of bent up bar will be over here, and after this, that is this 50% of steel and this 50% of steel, again this 50% of the steel and this 50% of the steel will satisfy the steel or not. We have to study it first, and thereafter we have to provide, if required, we have to provide the steel in the form of an extra top bar at the support. Okay, now suppose this part at this point. Here what will be what is still required over here? 338 mm square. Now how much steel will be available over here? The steel available over here will be, first this steel, that is 390.8 Then the second steel will be plus 257.4, and as 50% of bars are available, 50% of bars are available, we divide it by 2. We divide it by 2. So what will be the amount of the steel available over here? Here steel will be available of 323 mm square approx. Okay, if you do it on the calculator, you will be coming to know this value. And how much amount do we required is 384. Okay, then subtract this 323 from this 384. That will be the extra amount of the steel required for this support. Okay, got this point? So this is how we calculate the extra top bars at the support.